Hey everyone, so today we'll be going over another LeetCode tutorial and we'll be going over LeetCode question number 200, a number of islands. Now, this is a LeetCode difficulty of medium and it's quite a fun problem. Depending on the solution you choose, some may be easier than the others, but I'll be talking about the different solutions and I'll be showing an example of the solution that I find the most easiest and most intuitive to follow. So let's get started and let's start by reading the prompt. So given an n by n 2D binary grid, which represents a map of ones, which is land, and zeros, which is water, return the number of islands. And an island is essentially surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may also assume all four edges of the grid are all surrounded by water. So looking at example 1 here, to just get a better idea of what we're looking to solve. We have this grid here, and we essentially want to find how many islands are found within this grid. The expected output is 1, and why it's 1 is because you can see here, this all of these ones here that are found in this group, they are all somehow connected vertically or horizontally, as the question or the prompt mentions. And we can see that each one, you'll either find a horizontal or vertical connection, and those connections form one entire island. The rest is all surrounded by zeros, which is considered water, and the outer bound is also all considered water. So therefore, we have one island here. Looking at example 2, we can see that using the same approach, we have a group of ones here, of these 4 ones in the top left corner, which is considered one island. But this one over here, it's not connected vertically or horizontally. I guess you could say it's connected diagonally, but we only look for horizontal or vertical, like up, down, left, or right. We're not looking for vertical connections, diagonal connections. So this is considered its own island. Similarly here, this is also the third individual island. So that makes this group of 4 ones one island, this the second island, and these 2 ones over here, the third island, and that's why the output is 3. So how would you go about thinking about this problem? Essentially, I have a sample grid here, and I'll be kind of walking through and showing you a good way that I think personally to think about this problem. So as I mentioned, there's a few different methods to solving this question. You could use an approach like breadth first search, where you search by level, and you can keep a queue and track how many ones are seen and what's surrounding those ones. Another method is using a disjoint set. Personally, I think that a disjoint set might complicate things. It might not be the most intuitive solution to code up. And the third solution, and the one that I'll be showing you, is using a DFS or depth first search. Over here, DFS or depth first search, where essentially we hone in on one element and we keep drilling down deeper and deeper into the depths of that element. For example, we will keep going. We'll get this one. We will see up, down, left, right. If there's another one that's found, and if so, go to that one, check up, down, left, right, see if another one is found. Keep drilling down deeper and deeper until we have no more ones that we can be found, and there we have one island in that case. So that's essentially the DFS approach. Feel free to look up more about DFS, BFS, or disjoint sets. There's some other good explanations out there for the other 2 methods that I've mentioned that I'm not going to be showing here. But in terms of DFS, a good way, as I just mentioned, is kind of just drilling down deeper and deeper. So for instance, say we start off at index 0, 0. So essentially, the row 0, column 0. You could consider it that way. So here, we can maybe set some condition that if there is a 1, which in this case there is, then check the elements above, below, left, and right of it to see if there are any connections that can be made or found. Meaning that we've identified a piece of an island. Let's keep searching all horizontally and vertically until we could discover like the next piece of the island, and let's keep doing this until we've gotten all the pieces of our island. So okay, we have a 1 here at the 0, 0 index, right? So let's search up. Okay, we can't search up because that's out of bounds. Let's search left. We can't search left because that's out of bounds. Let's search down. Down, there's a 0, so there's not a 1, which means that there's no continuing island downwards, so there's no point of continuing that search. And then right, we see that there's another 1. Cool. That means that we found a connection. Let's now do the same set of rules to this connection and keep going deeper and deeper into the depths of this island. We'll search up, out of bounds. Left. Okay, we see here essentially the left is going to show that there's a 1, but we've already seen this 1, right? We don't want to be like, okay, there's a 1 here that we just saw. Let's search. Let's perform the DFS again. Let's search up, down, left, right, and it'll just essentially be going back and forth continuously. So what we'll do is, after we've seen a 1 or part of an island, we will maybe mark it as seen or something. Like put a check mark. We'll mark it as seen in our code. And I'll show you how I kind of mark it as seen in our code. We will essentially just in place modify the grid and make this 1 turn into like a hashtag or something, like just a random symbol, so that it's not identified as a part of an island. It's just now it's like a hashtag, like it's marked as seen. So okay, we go left, that's marked as seen, so let's not continue there. Let's go down. Okay, this is another part of an island. Let's use the same rule because we're going deeper into the depths of each element. So we'll go up. Okay, this is marked as seen, like we had marked it as seen, so no point of going back there. Left, it's 0, so no point in going there. Down is 0. Right, it's 0. So okay, that means that this is done. Like we've finished seeing this one, and this can be marked as seen, but we have not gone right here yet. So we've only gone up, left, down, and then after going down, we continued following the depths of it, going checking up, down, left, right for this element. Now we have to finish our search by going right here, and we see that okay, after going right, we see another 1. Let's go up, left, marked as seen, so no point of going there again. Down, 0, right, out of bounds. So this is marked as seen, and now we have completed our first iteration of performing our DFS search, and we have identified our first island, which is now this big chunk here. That is our first island. When continuing on with this approach, we'll go to the next element until we reach our next 1. And mind you, since these will be marked with another symbol, such as a hashtag or something, these should not be coming up since we've already explored this island. So we'll be going to next. That's a 0. That's a hashtag. We've seen it. 0. Let's go to this one here. Okay. So we see that this is our 1. Let's mark it as okay. We've seen it, and let's go up. There's a 0. Left, out of bounds. Down. Okay. There is a 1 here. Let's continue with our search. Let's mark it as seen. Let's go up. Okay, this is seen. Let's not continue that. This is left. This is out of bounds. Down, out of bounds. Right, 0. Let's not continue. All right, we have seen this one. Now let's continue back here. We still haven't gone right here, so let's go right here. And we will see that this is 0, so we won't continue. Okay, our next iteration of like our DFS search is complete. We have found our second island here. Let's continue to traverse the grid. We'll go here 0, here 0, here it's seen, here it's 0, here it's 1. Okay, so let's mark it as seen. Let's go up 0, left 0, down, right, both out of bounds. Okay, so we've essentially done our DFS. Third island has been found using DFS, and since it's only one island, like this is our third island, for a total of 3 islands. And then our DFS search would be complete since we've reached the final element of our grid. So I hope that was clear, but essentially, we would parse through the grid, mark the seen elements as seen so we don't repeat them, and keep going and drilling deeper and deeper until we found all the ones that are connected, and then keep going until we found like our next one, and then find those connections, find the next one, those connections, and all the meanwhile we would like be keeping a count of all the islands we've seen. So every time we hit our DFS search, we will increase like the count by 1, basically. Now, the 3 key things to kind of remember here are that we should be defining our bounds so that we could do a bound check, so that if we are out of bounds, we automatically know that, all right, we don't have to continue searching because that search would be out of bounds. So I'm just gonna write some key notes here, like key things to track. So we should be defining bounds so that we know when we are out of the bounds, and since it's all considered water, like we don't have to explore outside of the bounds. We should be we should have a good way of traversing up, down, left, right, so that we can keep track of things, and we could search vertically and horizontally. So traverse up, down, left, right. And also what's important is marking these elements as seen in place, so that when we are performing DFS and we get to, say, element 1 in our grid, if we check up over here, like we don't repeat this search for no reason, because technically we have already done this search. We're already in the middle of it, so it's marked as seen. We should not repeat it. So mark seen elements in place. Okay. So these are like some of the key things to track when performing DFS. Now, what we can do is we can hop straight into the code, and we could talk about how each of these key things are defined in code. Okay, so to get started on coding our solution, let's first get the length of the rows in our grid and the columns in our grid, and from there we'll create some conditions to determine what's considered in bounds, out of bounds, and we'll go on from there. So to get the row length, we will simply just get the length of our grid, which is essentially going to be the length of all of the elements in our grid. And in this case, for example, if we look at example 1, it has 4 elements. Since this is like a 2D array, the first dimension is just going to be the rows, and there's 4 elements, and that which means that there's essentially 4 rows. To get the columns, or the column length, we'll be getting the length of grid, but we'll be getting the length of the first element of the grid. So essentially, the first element is a row, and in the row there is there's a certain number of elements in there, and that essentially each number, for example, like 1, 1, 1, 1, 0, each of those is going to be like a column. So like, this is going to have 5 columns, and basically there are 5. The length of the first element in the grid is 5. So this matrix in particular has 5 columns, and we would do that by getting the length of the first element in the grid. So now that we have that, let's create start defining our DFS method, and we can from there create our boundaries. So for our DFS method, we will pass in a row index and a column index. And here, so whenever we will be going through our grid, parsing it, here are the conditions that essentially need to be met. So here is where we will set our bounds and conditions. So basically, the row length has to be, and the column length, they both have to be, or the column and the row index have to be either 0 or greater than 0. So it could be 0, which is like 0, 0, for example, over here. It could be 1, 2, 3, 4, like that's the lower bound, and then the upper bound, it has to be less than the length of the row or the column. So like, what does that mean? For example, here, this row, it has a length of 5, but since we start counting our indexes with 0, it's essentially going to be 0, 1, 2, 3, 4, and 4 is like the last element. So it has to be less than the length, which is 5. So how we will kind of write that out is we could just use an if statement when we'll have our like row in the middle. So if row end, if 0 is like less than or equal to row end, so basically row end is like greater than or equal to 0, and row end is less than the entire row length, then that means our row index is good, it's passable. Similarly for the columns, if call end like that and it's less than call length, that is also good. And then our last condition that we'll be checking is we'll only like perform DFS and keep parsing through and through if we see a 1. So we have to just keep seeing a 1, and that will be our condition to parse through it. Equal 1. Okay. And there. Cool. So we set our bounds and conditions. Now, what happens when we first, strike upon our first one? As I kind of mentioned here. Okay, so we defined our bounds. We could put a check there. As I mentioned here, we should first mark it as seen so that we don't look at it again, and it's kind of marked as seen and it's out of the way. So to do that, I said that I'll use like a hashtag symbol. You could use any symbol that you want as long as it's not a 1. Call end equals so that essentially is going to mark element as seen. Now that the element is seen, we can cross that off. Last, we have traverse up, down, left, right. So to do that, here's kind of the method I use. I kind of just add 1, subtract 1 from each index. That goes up, down, left, right. So let me just write it out, and then I'll talk about that. So just traverse up, down, left, right. Okay. So how I do that is I have an array of tuples, which I'll show. So essentially to go up, I'll have a tuple. And what does it mean to go up? Essentially, say we're over here in row 1 and column 0, and we want to go up to row 0, column 0. What that means is we have to subtract 1 from our row index, right? So consider in our tuple, in our tuples, like the first element is going to be the row index and the change we're making to the row, and the second will be the column. So to go up, we're going to subtract 1 from our row, and we're going to keep the column the same. That's going to make our overall coordinate move up 1 point on the grid. Similarly, if we want to go down, we will add 1. So basically, if we look at our grid here, we're over here. We want to go down to so we're at row 1, column 0. We want to go to row 2, column 0. We add 1 to our row count or row index. So it's going to be just a positive 1 and a 0. Similarly, left and right, we can do the same, but we won't touch the row. This time we're going to be touching the column. So say we're at like column 1 and we want to go left, we're going to subtract the column index by 1. If we want to go right, we're going to increase the column index by 1. So it's going to be -1 for left and 0, 1 to go right. Okay, so now that we have defined, or now that we are traversing it like up, down, left, right, we have to just get the new coordinates. So this is going to be new row ind. It's essentially going to equal current row ind plus the x coordinate. We'll do new call in equals call in plus the y coordinate. Oops. And lastly, I have to put it in here. Okay. And lastly, we will, it meets all these conditions. Now we are going to go up, and we're going to perform our DFS again. We're going to go down, perform the DFS again, like perform the same search. Left, perform DFS again, right, perform DFS again. So our last thing we have to do is you have to just call the DFS again with our new row index and our new column index, basically. So, now this is how we will essentially traverse the going up, down, left, right. So now this is done. Our DFS method is complete. All we have to do is parse through the entire grid, and if we identify a 1, we're going to increase the count, meaning, okay, there's an island that's found, and we're going to just perform DFS on this. So now we could just set a count of 0, which will be what we start off with, and then we'll just go through element by element of our grid. So before I in the range of row length, for j in the range of column length. If we see an I, or a 1, so if I j equals a 1, that means that, okay, let's perform our DFS and let's increase our count by 1. So DFS of ij, let us increase our count by 1, and then let it go through here, and let us return the final count. So this is how our overall solution should look. Let's submit it. Okay, and we see that it's accepted. Beats 91% for in terms of runtime, 82 in terms of memory. Talking about the big O of this really quickly, we see here that we are iterating through the rows, all of the rows and all of the columns. So essentially, our big O for runtime would be O of n times m, where n is the number of rows and m is like the number of columns that we are going through. So rows, columns. So yeah, this is the solution as you can see here. Hope this helped. Good luck with studying, and good luck with your interviews. Thanks.